Hello. So for our last video, we're going to take a look at document 3. So you'll notice that this graph has been provided for you here for our answer to question 1. So if you were doing this utilizing the Logger Pro software, you would pull up your data and then submit a screenshot as your answer to this question. But we can see that there are drops here collected or data collected points for every 4 drops. And then these are the temperatures that are referenced in the graph. So when you're asked about components 1 and 2, our first component would be the one that distilled first. So based on this graph here, we reach a temperature. It looks like the highest point is like 77.1 or so from our data over here. So that would be considered the boiling point of our first component. And then when you reference the highest temperature on the right-hand side of the graph, that would be our boiling point that you should list for component 2. So when I'm referencing these questions, component 1 and 2, that's going to be question 2. Tell me what the identity is of this first component. Remember, we have 2 options. We have ethyl acetate, and then we have butyl acetate. And so those can be either component 1 or 2. You have to make an educated decision as to which would be referenced as component 1 and 2 based on their boiling points. So again, those questions will come from that graph there. So then we have our gas chromatography results and analysis section here. So anything in pink, this will not be entered on your document 3. This is what you would provide. This information can be found in document 1 when I mentioned the parameters used to obtain the gas chromatographs. Let's see, what else do we have here? I mentioned you use your initials here as your identifier. And now these are the gas chromatograms that have already been analyzed for you. So if you were just given this data, you would pull it up in Logger Pro, and then we would find the area from this point to that point there. So the area under this curve. This is our standard for ethyl acetate. So the retention time listed down here, we're going to use in a later table that I will reference. So again, the standard for ethyl and butyl. Notice they each will have 100% area because there's only one component. So that's ethyl. Here's what a butyl acetate control curve would look like. Again, 100% area. Here's your retention time for your table later on. Now we have this, this is a third standard. This is now our mixture of a 1-to-1 molar percent, where we could consider this 50 to 50% of both ethyl and butyl acetate. Notice the areas down here generates an 18 to 81%. So we're going to use this graph in our later calculation to calculate what's called the response factor. So I'll make a note here that this graph will help us find our response factor, because we know that these should be coming up 50%, 50%, but for some reason they're not. So now we have our undistilled mixture. So we have a known 1-to-1 molar ratio. Now this is the 1 milliliter that was left that we did not distill. We did not subject to our fractional distillation. So notice the percent areas that were returned. Again, we have component 1 that that hit our detector first, right? It distilled out for, or rather it passed through our GC first. So we assume that to be ethyl acetate as they're named below here. So instead of just calling them component 1 and 2 or compound 1 and 2, we're going to make an educated guess here that's going to be ethyl for compound 1, butyl for compound 2. And we have these percent areas that were determined for each of these curves here. And their own retention times here, but these are from a mixture. So keep that in mind, and why they might be different from our standards of ethyl and butyl acetate. Now, this is the fractions or the cuts that are referred to throughout our distillation. So I mentioned our first cut would be our first 10 drops here. So that's what this is going to reference here, our first 10 drops. Then we have, if we move down here to our a second fraction, our second cut. Now we have two components shown. Notice in our first cut here, we only had that one component. And again, first 10 drops, we expect that to be ethyl acetate coming out first. Now we have that this first peak here that looks very similar to our ethyl acetate peaks before. And then we have a second component, which will be assumingly butyl acetate. We have some percent areas shown here after we found the integration, the area under the curves. And then this is our last cut. So as we expect, we have a majority of our second component, our butyl acetate, and we can see maybe a tiny bit that's coming up about 0.3% of the area for our ethyl acetate. So we're going to analyze each of those chromatograms separately in the last video that you take a look at. But remember, I said those standard values. This is where we would put in those retention times right here from our control samples. And I tried to organize what your table, where you would find this information. Anything in pink here, you're going to find from the analyzed chromatograms. And then anything in blue over here, I will show you in the last video how to calculate our mole percents generated from the percent areas that are shown in pink here that will be pulled from those chromatograms. So again, the last video, we're going to take the info provided on the graphs and then do some calculations. So again, you're asked here to make some determinations. What's your first and second component? After the last video, you'll be able to answer question number 15 here. And then when it says show how you derive these values, you can either give me, handwritten sample calculations or type up some sample calculations here of those mole components or mole percent compositions. And then the last questions in your post-lab document here, you're just asked to describe the changes in the mole percent during the distillation. So again, at the start, cut 1 would be the first 10 drops. The middle, I forgot to reference, but that's the sharpest increase in temperature. We would have collected 10 drops in the middle of our distillation, and then whatever we can collect at the end, hopefully another 10 drops will be cut 3. And then please give me, an answer to this last question. Based on our data, can you completely separate two esters? So stay tuned for the last video, which will show us some calculations.